Hi, we're at the AMD Demo Showcase at the Advancing AI event. We're here with Bryce to talk about some of the AI open ecosystem that AMD has. Bryce can kind of go into high-level detail on that. So Bryce, I'll turn it over to you.
Yeah, in this section specifically, we're talking about ROCm and how ROCm is being brought to bear on a lot of application software. And we've got a couple of demos showing how they can take their existing code and drop it in seamlessly so it can be run on an instinct GPU and deliver breakthrough performance from both Lamini and Databricks here. Of course, ROCm is our application software, is our compiler software that's good for applications. The only thing that's really important from a detailed perspective, and it is teased out in our Databricks demo, is that ROCm is now upstreamed into the PyTorch code, which allows a lot of AI developers a more seamless move to take their applications and get them run them easier with our compiler tool on our accelerators. That's kind of a big deal for me.
We're at the MI Instinct 300X, 300A section here with Tyler. He's going to give a little more overview of this section. So Tyler?
Yeah, sure. So right here we have the 300X and the 300A. Here are the actual chipsets here. 300X on this side, A on that side over there. This is the 300X with just the small heatsink on top. And then if we go in that direction, we'll actually see a collection of 300A chassis and servers. So Supermicro, Gigabyte, and HPE. This one is similar to the one that's going into the El Capitan system, And then on the other side of this room over here, if you follow me this direction. Oh, excuse me, sir.
Sorry, I'm sorry.
Here is the 300X, the Instinct platform. It's 8 of those MI300Xs all on a UBB tray on top of an OCP platform. So any server that is based on the OCP platform, this would actually drop into. That speeds that time to market. And then here are some examples over here of those servers that take advantage of that platform. So here is the Azure platform. These VMs will be coming out next year. And then we have a Gigabyte, a Dell, and Supermicro box over here. And that's it on this space.
Did you just want to recap again the advantages of the MI300X? I know it would have been explained in the keynote, but just a sort of a high-level overview of why people should upgrade to this particular brand new architecture platform.
So in terms of jumping over to 300X, you're going to see the massive advantage for this GPU is going to be the memory and the bandwidth and the capacity in that regard. 192 gigabytes of HBM3 and 5.3 terabytes per second of memory bandwidth. For 300A, I'm going to jump ahead just a couple slides, and I'll show you, again, there's a memory advantage, 128 gigabytes of HBM3 for the 300A GPU. And then also the other big advantage for that is the packaging technology. It's an APU, so we're including GPU and CPU in the same package. You actually have 24 Zen 4 cores, 228 GPU CUs, and as I said earlier, 128 gigabytes of HBM3 memory.
Just briefly tell me about how soon they'll be available in the market and your expectations for people to upgrade so they can take advantage of all the benefits.
As you heard today on stage, we have a number of partners that announced offerings that are coming to market. You'll see a lot of them either announced like you saw today, or they will be coming to market in 2024.
So our next section here is the Ryzen AI section. We've got some Ryzen AI laptops that are showing off our IPU engine, and we're here with Xi to talk about some of the performance. Go ahead.
Hi, so here we have, these are HP laptops with the 7040 series APU, and these are NPU enabled. And the application that we have is Topaz Video AI. Currently this product is mostly GPU accelerated, and for the demo we have offloaded one of the functionality, motion deblur, and that is able to run on the NPU instead of GPU. Here you have the input, frames are blurry, and then the output that has been deblurred. Over here is the same demo, but we're also playing a game to show that we have GPU capabilities still to do other things.
Hi, so this is Ben Lewis. He's going to talk about the Arc Runner demo. It is also optimized for Ryzen AI as well. So Ben, go ahead.
Sure, yeah. So over here at the Arc Runner, which is OEM, and this is some of their software prototype. So with this prototype, it's kind of showcasing and utilizing is AMD's segmentation technology, specifically matting in this instance. So what you're able to do is, I'll kind of show you over here, is in real time, it's able to take a video. So this is just shot on phone. And segmentation is able to identify a human in the foreground, and then it can remove out the background. So without that technology, you need something like a green screen usually, or to actually sit down and like figure out the key for the color, and like, you know, hey, how do I get the red background? And there's a little bit of red on the shirt, and you have just a long process. So this is in real time able just to streamline that whole thing. You know, for things like if you're a content creator or a streamer, you could just set up your stage with Arc Runner, which is, you know, it provides the 3D stage. You can add props, lighting, spin the camera, things like that. Yeah, just to make everything really easy. And so, yep, currently this is on the iGPU. It's what it's running on, and by the end of Q1 or so, to be on the IPU.
It's amazing to think that this is like brand new technology. It's obvious that just in a couple of years, everybody will take this for granted. And the things that we thought were difficult all of a sudden become easy.
Exactly, yeah, and they're only, you know, this is only getting better. So every day, since this is AI, we feed it more videos, and it gets clearer and clearer at identifying human, right? It's only going to get better from there.
Yeah, have you seen that new text-to-video creator called Pika.art, Pika.art?
I don't think I've heard of that one specifically.
Yeah, that came out just in the last week as we're recording, and I'll show you the video off air, but it's amazing. And to think that you can do all that in the future on the AI engine of your PC without having to go to the cloud, well, that's what we want.
Here we are with Apostolos. He's going to talk about our epic performance. Kick it over to Apostolos.
Yeah, hi, nice to meet you. So this is a demo about doing AI inference on a CPU, and it's a comparison between the top-of-the-line 9655 dual-socket EPYC system and a top-of-stack 8480 plus Intel Xeon system. So what we're showing here is that you can have a higher AI throughput performance when you're using EPYC versus Xeon because of the higher number of cores, the superior memory bandwidth, and the ability to run, you know, software without having to recompile for, you know, different kind of ISA extensions. And we are comparing for the two Llama models, 7 billion and 13 billion, with different token sizes, and the performance delta is up to 36%. Okay, so this one shows a whole end-to-end AI inference pipeline. So you see, this is a benchmark called TPCX AI, and this is a comparison again that has all stages in order to produce AI throughput performance. So you have loading, training, inferencing, scoring, and then at the very end you also test throughput. So we saw that the EPYC solution is actually able to complete the whole task holistically faster, again due to the higher core density, memory throughput, and this one is based on floating point 32, and the performance delta is 2.25x. When you have a single socket 32 core EPYC 9374F versus a dual socket Xeon with 64 cores, 8462Y.
We're here at the Radeon AI section, and here's Matthew Letts to talk about some of the Radeon AI demos.
So we're showing two of our top GPUs. So this is our consumer RX 7900 XTX, and over here will be our W7900. The demo we're showing is image generation using the Shark UI from the company we recently acquired, Nod AI. So using various control nets and some background images, we can help guide the images that are being generated to be more what we want. And it's all being run locally on the system, so anyone with a Radeon GPU could do this themselves at home. And you get great looking images that you can use.
Stable diffusion on your desktop.
Stable diffusion on your desktop. We have another demo of stable diffusion running in Comfy UI, but this is running on using the ROCm backend, so ROCm running on Radeon. using Comfy UI and the new SDXL Turbo model that just came out, which can generate images in a single iteration. So you almost have real-time image generation. As you type, it's generating those images very quickly, less than a second. And so it's currently an experimental model, so you get some weird results sometimes with funny feet and legs and fingers. But if you're just working on prompt engineering, it's a very fast way to test out words and prompts and see what you can get.
Who is the chief AMD prompt engineer?
Definitely not myself.
You need one.
We need one.
Fun,
we need one. I think prompt engineering is an art on its own.
It is.
It is. So do you want to move to the second one? So the second demo we have is showing off our Radeon Pro workstation graphics cards. And so the main difference between the consumer side and the pro side is the larger VRAM we have. So this is the W7900 with 48 gigs of VRAM. And what that means is you can put a larger model on the PC. So here we're running Llama 70B, which typically would need either lots of GPUs or run in a data center, but you wouldn't be able to run it locally. But we have the Int4 version from the Not AI guys running in the Shark Studio. And it takes up about 40 gigs of VRAM. So if you have a GPU with 40 gigs, you can fit this in your GPU. And then you can very quickly run prompts, creative prompts, and use your chatbot. And so what that means is if you can test all the latest models of almost any size, and then also for folks that want to do fine tuning of their models, you'll be able to take it and fine tune it with your own content and personalize it. They got stuck. Oh, there it goes. I think it was trying to, someone was asking for it to give testimony from a bank robber before, and then I think it was trying to create a joke based on the bank robber.
Yeah,
so it was like trying to be...
It was trying to do context.
It was clear it?
Yeah, you can clear it and run it again, but yeah, it was trying to be in context.
That's
fine, yeah. But I mean, it's cool that it was trying to deliver context. I mean, that's like, it's trying to understand.
It compounds on things as it moves down.
Yeah, which is what modern AI advanced assistants are supposed to do.
Yeah. So much faster when it's just a joke on its own. The jokes aren't great yet.
Sure,
but
just do that demo one more time.
Yeah, I'll
just explain it what you're doing.
Yeah. So we can use the Llama 70B to tell jokes and run chat, but you can also then take your own personal content and fine-tune the model. So if you wanted to have a different data set or your own personal data in there, with a workstation you'd be able to do fine-tuning, do the fine-tune training on the system, and then run it locally as well, and you'd have a very powerful AI system.
How long do you think it will be before everyone just has a very sophisticated, like ChatGPT 6-level device in their pockets and desktops?
Not long. So a few months ago, we were going to do this demo on 4 GPUs because that was the only size it would fit on, and now here we are running it on 1 GPU. So it's moving very quickly.
The future is coming fast.
Every week is the future.
We're here with Ryan to talk about a couple additional AI demos. We've got a Smart Edge server and a Universal AI demo. So here's Ryan to talk about these.
Hello, my name is Ryan Rajbi. I am the systems architect for video analytics at AMD. So what you see here is AMD Universal AI Edge demo that's showing an automotive object detection and classification. This is a simulation of 4 live video streams at full HD resolution coming in and in real time being processed by the Versal device that uses the AI engine XDNA technology for inferencing. So these are 4 concurrent video streams running at 30 frames per second using a ResNet detection and classification model. And the output is within real time, so there are no dropped frames, which is critical to have a low latency solution for an automotive safety critical application. And what you may not be able to see from the video, possibly you can, is that it's detecting and putting a bounding box around vehicles and putting in a different color-coded bounding box for the different types of vehicles. Cars are in green, and vans are, and trucks are in yellow. And yeah, and so that is the AMD Versal AI Edge automotive object detection classification demo. What you see over here is our Smart Edge AI server. So this is an AMD Ryzen embedded CPU, an R2000 series CPU, paired with two Zynq UltraScale Plus ZU5EV PCI accelerators. So they're in a small form factor. So this is really a small, low profile, low power, under 75 watt edge server. And this has many IOs. Most importantly, has out-of-band management, and it has two 10 gigabit Ethernet interfaces, so it can aggregate more than 32 video streams of 1080p at 30 frames per second, and it can run inference on them. And so right now we're just showing a couple of examples of doing an automotive traffic analysis, so detection and classification in a traffic scene, as well as a smart retail detection and classification as a detergent put up. And so this is really an ideal system for aggregating many video streams and running video analytics for industrial use cases, smart retail, if you're thinking of a smart checkout system, or any type of surveillance, and smart city applications. So, yeah.
So we're here with Stanley. He's going to talk about Nod.ai. Stanley?
Sure. So Nod.ai, we're now part of AMD, and we are building this software called Shark. So what's Shark? Shark is this AI compiler that allows you to run large language models on any sorts of hardware, and the latest and greatest Gen AI on even the smallest devices. So right here, we have your regular ROG Ally, which you could buy off Amazon, and it's one of our tiniest, GPU devices. And if we could get it to run stable diffusion, just by, let me just show you a sample. And this will take just under 20 seconds to generate images. And with the same stack, with the same code, you can run large language models such as 70B. So this is the largest Llama 2 variant running on my home GPU at home. And you could make it do, okay, just real quick. This is a Babel generated image of the Babel building. And in here, you could ask it to write a poem on AMD Advancing AI. So this is on my home GPU, and it's running the largest 70B Llama variant with the same code. So it used to take months and to develop and optimize code for different hardware of different form factor. But with Shark, you can just, with a change of a single keyword such as, hey, the ROG Ally, or hey, the 700 GPU, you can get it almost immediately. And it also runs on the laptop. So this is running on the G14 laptop, running Llama 700B.
And it looks very comparable to the sort of speed you get from ChatGPT or any
exactly,
other. And
exactly.
that's all cloud delivered. This is local on your
exactly,
device.
Exactly. So with Shark, you can have your privacy without the loss of quality.
And you can obviously train it on your own data.
Exactly. And you don't need to upload all your private data up into the cloud somewhere. It's all at home.
Locally stored.
Yeah, locally stored.
Is this something that will only run on AMD hardware, the CPU, APU, and GPU, or can it run on any x86 processor?
It can run on CPU, GPU, soon to be on the APU, but it can run on x86 processors and any GPU you can imagine.
Obviously, you'll get the best performance if it's on
yes,
AMD.
Exactly. Yeah.
Thanks for coming out to the Advancing AI event. Thank you.